Hi everyone, today we are working on lesson 2, the axis of symmetry. The axis of symmetry is a line that cuts the parabola into two symmetrical pieces. So we're going to learn how to find that by looking at a graph and also by looking at an equation.
All right, so today we're on lesson 2, the axis of symmetry. Learning target is I can calculate the axis of symmetry by analyzing a graph and an equation. So the axis of symmetry is the vertical line that cuts the quadratic into two symmetrical pieces. So symmetry means when you cut it in half, it's going to look identical on the left as it is going to look on the right. So you must always state the axis of symmetry as an equation of a line. So a vertical line is a line, so you have to write it as an equation. So the equations of vertical lines are always x equals some number, because vertical lines actually are not functions, because if you draw that vertical line to do the vertical line test, it's going to intersect in literally every single spot. So that's why there's no y in our equation. Okay, so x equals some number, and that number is wherever it intersects the x-axis. So it kind of sounds confusing when I explain it, but when you see it, hopefully it won't be too bad. So to calculate the axis of symmetry when analyzing a graph, your equation is just the x-coordinate of the vertex. So let me say that again. The axis of symmetry is just the x-coordinate of the vertex. So if you think about it, the vertex is your turning point. So that's where it changes. So that's where you would cut your parabola in half to have one symmetrical side to the other symmetrical side. So to graph the equation, you draw a vertical line through the vertex. The axis of symmetry is also graphed as a dotted line. So always label the axis of symmetry with your equation, which again looks like x equals whatever number we're going through. So it's kind of tough on Google Docs to do these notes, I'm going to be honest. So if you do have the physical copy, I do suggest you do that on the actual hard copy for these notes, because I can't really show you. I mean, I can draw my line on here, but there's no way for you to do it. So let's just look at this first example here. Okay, so your vertex is at 1, 3. So if I were to draw a vertical line to cut this parabola in half, it will go right through the vertex. Okay, so when I graph this vertical line, do you see how it intersects the x-axis at 1? So that's my equation, x equals 1. Okay, now when you graph the axis of symmetry, it's a dotted line. So I didn't do the dotted line with my red just because that would have been more complicated. But on the answer to the right, that's what I have. And if you notice, we could have just found that from looking at the vertex x-coordinate right here. So our axis of symmetry is x equals 1. Okay, looking down below, it says you try. So I want you to pause the video and give this a try yourself. Okay, check your work with my work. Now, after we found the vertex, you really can just calculate the axis of symmetry by looking at the x-coordinate of the vertex. Okay, but if you're on your physical hard copy, you should be drawing in your axis of symmetry, which means we're drawing this vertical line, vertical dotted line, through the vertex to cut the parabola into two symmetrical pieces. So that would be my line, and I always have to label with the equation of my line, which is x equals -2, because it goes through the x-axis at -2. So the next part, it says, now I normally wouldn't have erased that, but it kind of does some weird things when I move it around. Okay, so down below, see, it's already being weird. Down below, we're going to now calculate the axis of symmetry using a formula. So we can calculate it from looking at a graph, just by looking at the vertex and stating that equation of the line and graphing that line. But from an equation, you have to calculate the axis of symmetry using this formula, which is -b over 2a. So the a and the b come from our standard form of our quadratic, identifying a, b, and c, and then you just simplify it. So I have an example here for you. We've got y equals x squared minus 6x plus 4. This equation is in standard form. So we first identify a, b, and c, even though we really don't need c. So my A in this equation is 1. My B is -6. So I plug that into the formula. By the way, this formula is not provided to you in any reference sheet, so you do need to memorize this one. But there's always a way to get around it. So here we've got x equals -b. So my b value is this -6 right here. So -6 all over 2 times a, which is 1. Now we have a double negative here, -6. So that turns into a positive. Divided by 2 is 3. So my axis of symmetry is x equals 3. All right, so taking a look. Number 1, let's do that one together. So we're going to state the axis of symmetry for the following quadratic functions. So got to first identify a, b, and c. A is 1. B is 2. C, not like it really matters, but is -3. So now I'm going to go up here. This is an equation typed in for you. I'm just going to copy and paste that. My b value is 2. My a value is 1. So that gives us -2 over 2, which gives us -1. So my axis of symmetry is x equals -1. All right, number 2, hopefully you're noticing that this equation is not in standard form, it's actually in vertex form. If you remember what we learned in lesson 1, we can first identify the vertex right from looking at this equation, opposite of what's inside the parentheses. So it's a -1 inside the parentheses, so for the vertex it's a +1, and the same sign for outside. My axis of symmetry is just the x coordinate, x equals 1. Okay, so you have 2 more to do on your own. One is an equation and one is a graph. Pause the video and we'll come back and check. Okay, check your work with my work. And that's all I have for you for today. If you have questions, please let me know and make sure you self-assess for today's lesson.